Hey, how are you guys doing? Professor Rhines out in the elements. This is the last one for the 2019-2020 school year, so this one's gonna rock. I'm way out here in the middle of nowhere today. I could scream at the top of my lungs and nobody would hear me, which is a perfect place sometimes for Mr. Rhines to have a science lesson like this out in the middle of nowhere. Wait till you see where I'm at. Besides along the river. Yeah, got a little site set up here with a campfire. So let's get started. I have some experiments for you. Then I'm gonna cook dinner. All right, hey, let's get started here. You guys like my saying for your class that I showed you the other day? Our new class motto that'll hang on the back of our wall that says, hey, how you guys doing? Peace out, we love you guys. That'll be kind of fun. Hey, we've been talking Isaac Newton. And Isaac Newton had 3 laws of motion. A 1, a 2, a 3. It's pretty easy to remember number 1. It goes up and down number 1, just like this looks like number 1. So number 1, inertia. Number 1, inertia. 1 and inertia. It's one way to remember it. The second one has to do with acceleration. And in fact, the formula, you'll learn this later in junior high, is that F equals M times A. Force equals that mass. This is mass. Force times this acceleration, the speed. So look, there's 2 C's. Acceleration, 2 C's, second law of motion. Inertia, number 1, and it looks like the number 1, but it's actually a letter I for inertia. Acceleration, 2 C's. It's how, when things speed up, but it depends on the force behind it to get it moving, plus how much mass, how much particles are packed into it. And then number 3, action, reaction. ACT, 3 letters. ACT, 3 letters. ACT here again, but it's act and act and act again. When you act again, that's react. So when there's an action, there's a react. 3 letters, ACT. I for number 1. Number 1 and I, a straight line, inertia. Number 2, 2 C's for acceleration. And 3, that action, reaction. So I'm gonna show you 3 quick demonstrations for each one of these. All right, here's number 1. I brought RC out here. See RC? Got him on the back of my frying pan. I'm gonna have a brat here in a little bit and cook up some asparagus, but before I do that, I'll show you. This is number 1, it's just sitting here. An object at rest stays at rest until acted on by a force. That's inertia. If we have a force and we get it moving, a force acts upon it. Now it'll start moving, and it should keep moving forever until a force acts on it. And that force might be gravity if it's on a slant, or friction as it's going over this textured bottom of the pan. It'll eventually slow it down, but it should just keep going forever. But it'll eventually, a force will act on it. That's inertia. Here's number 1, just sitting there, or number 1 moving, and then a force slows it down. All right, number 2. All right. For number 2, which has to do with force and mass and acceleration, well, here we have 2 things. I have this wooden dowel, and I've got this marker, and they're both about the same size, but the dowel is heavier. So if I want to get it to a certain speed, I'm going to have to put a certain amount of force in it to get this to start rolling. Same thing with the marker, but it takes less force because there's not as much mass to it. Plastic is lighter and it's hollow inside. This is dense with particles all the way through it. So as I get this moving and I push, it takes a little bit more force to get its mass going compared to this. Newton called this second law of motion. It has to do with acceleration, and that is based on the force and the mass all involved in that speed that it takes to get something moving. Rule number 2 from Isaac Newton. All right, here comes number 3. All right, here's number 3. We had simple toys as kids growing up, and I always took care of my toys. I always say that. I took care of my toys. So this is one of them. It's a magnet, and it comes, let's start that again. It's a magnet, and it's gonna slide down this by gravity. We're talking about gravity, and all of a sudden it comes in, and it's on the inside. Inside, on the outside. Action, look, the reaction. I'll get this thing really moving. Watch how fast I can get this going. Action, reaction. Newton's third law of motion. When I stop this now in a minute, the action, reaction, it'll go on its own. Up, down, action, reaction. Action, reaction. It barely makes it up there. Let's look at that again. While I'm getting it going, let's review. Number 1 was inertia. An object at rest stays at rest until a force acts on it, or it stays in motion forever until a force acts on it. Number 2 has to do with force is the mass times the acceleration, and this number 3 is action, reaction. Action, reaction, action, reaction. So we can see all 3. Number 1 is inertia. Number 2 is acceleration, which is force, mass, acceleration. You'll learn that a little bit later down the line. And 3, action, reaction. But it all has to do with Isaac Newton, and it all has to do with gravity and this idea for every cause, there's an effect. Every cause, there's an effect. Something happens, something else is going to affect. Something else is going to happen. The effect, cause and effects, the reaction. All right, hey, that's it. I want to make this a little shorter because, man, I still have a math lesson. I still got to cook my dinner, and I got to hike out of here in some deeper water before it gets a little too dark tonight. So, peace out. We love you guys. It's been a great year, a different year, but a great year. And we're going to see you along the way.